Everyone. In this video, I'm going to show you one example of past year final exam question for continuous time and discrete time signals and system, which is chapter 1. So a question from chapter 1 will be one of the compulsory questions in the final exam. And for this example, I have chosen one question from past year final in 2015 and 2016. Let's see the first question. For each of the signals given, determine if the signal is symmetrically even, odd, or neither. So for this kind of question, if you see here, the marks allocated for each question is 2.5 marks. So it means that on top of answering whether it's symmetrically even, odd, or neither, you have also to prove. Okay, you have to show your justification why you answer even odd. So for the first question, xt is equal to 5 cos t. So in order to determine, we must draw to justify our answer. So for 5 cos t, we know that for cosine function, cos 0 must have the peak in the middle of the graph. So here is 5 and this is xt. Okay, and one cycle is equivalent to 2 pi. Okay, so if we see here, the signal here is symmetrical at y-axis. So we can answer this is an even signal. Okay, so remember that you need to draw to justify your answer. Even if you just answer even or odd or neither, you still you cannot get the full marks. Okay, so the key here is to justify. And question number 2 here is zt equal to sine t minus 90 degrees. So we know that sine t starts from 0, x equal to 0 and y equals to 0, something like this. However, for sine t 90 degrees minus 90 degrees, we have to shift to the right by 90 degrees. So for sine t, we have here 2 pi. Okay, and for sine t minus pi over 2. Okay, so we draw another axis, but now we have to shift it by 90 degrees. Okay, so where is 90 degrees? If you see here, the original sine t, we have 2 pi here, and we should have pi here. Okay, and this is pi over 2, which is 90 degrees, and here is negative pi over 2. So the point here should be shifted to the right. Okay, because the point here is 90 degrees, negative 90 degrees, so we shift to the right, and the point here should be at 0. Okay, so we will have something like this. Alright, and here is 1. Okay, because the magnitude here is 1. And here should be 2 pi, and here should be pi. Okay, so this signal is even. Okay, so if you want to check whether you have your answer correct, okay, if you're still confused whether you want to shift to the left or to the right, first you can also refer to the trigonometry identities. So all the formula for trigonometry identities is in the list of formula. Second, you can also check using your calculator. For example, here you want to check what is whether you have shifted correctly. So now let's say you put 0, okay, at t equal to 0. So sine 0 minus 90 degrees equivalent to sine 90 degrees. So if you key in your calculator, sine 90 degrees, sine negative 90 degrees is negative 1. So now you are sure that you have correct answer. Or you want to check again, so t is equal to pi. So pi minus 90 degrees is 90 degrees. So sine 90 degrees here is 1, which is also correct based on your drawing here. So basically when you draw, it is justified, right? So let's move to another question here. taken from past year final exam 2015-2016. Basically, I just took one question for this video for the final exam. So I took the whole question. If we see question B, this is also from continuous time signals and system. So rectangular wave in figure Q2B1, which is this one, is fed into a linear time invariant. So this FT is fed into the system here, linear time invariant system as shown in figure Q2B2. First, you have to determine the mathematical expression for GT. Okay, so we have GT here, which is the FT, the rectangular function, multiplied by 2 cosine 2 pi t minus pi. And we need to illustrate GT in domain graphical representation. Okay, in time domain graphical representation. So this means that we have to draw GT. Okay, so you have to understand the question. Illustrate in time domain graphical representation. Okay, so this will constitute 2 marks. Another one is for express mathematically the output signal HT here and determine all signals operation involved in the system. So the keyword here for number 3, you have two questions. First, you have to find HT in mathematics equation, and okay, don't forget the and here. Determine all the signals operation involved in the system. So don't miss this, because otherwise you will not get full marks, 5 marks. Okay, so if you see at the system here, this is the multiplication of FT with ST, which will result in GT. And then there is a summation here. It means that GT here is positive and you have to minus RT. Okay, if you see the minus here, it means that you have to minus RT. So RT is given as 1, then only you will get HT. Okay, even though this is summation, it can also be minus or plus depending on the sign here. So the sign here is negative, so you have to minus. Put the system here again. So we have to find the equation for GT. Okay, so first we have to find the equation for FT. So FT here is rectangle T. This is a standard form for rectangle in which it has 1 as the magnitude and it has 1 over 2 as 1 over 2 here. It has 1 as the width of the rectangle. So the width of the rectangle is 1 and it is symmetrical between y-axis, and it has 1 as the magnitude and also it has 1 as the area. So this is a standard form of rectangle. So the function here is this rectangle T. And then we have ST, which is 2 cosine 2 pi t pi. So from there we can get GT. This is very easy. GT is just a rectangle function multiplied by 2 cos 2 pi t minus pi. Okay, so you just rearrange. It becomes 2 rectangle t cosine 2 pi t minus pi. So that's it. Okay, this is your answer for question 1. So when you have answered this, you will get 4 marks. Okay, so it's quite easy to get 4 marks here. And then the next one is illustrate GT in time domain. So now we have to find GT. We know that anything that multiply this rectangle function, so only function that has only function that is between this negative 1 over 2 to 1 over 2 will appear in the final form of GT. Okay, and the magnitude also has to be multiplied together, which is 1 multiplied by 2. Okay, so now we draw 2 cos 2 pi t minus pi. So in order to draw this, we need to know the duration of the function, okay, of this function. Okay, so we have here GT equal to 2 rectangle t cos 2 pi t, and then we would like to plot ST first. So ST t is equal to 2 pi t minus pi. So in order to plot this, we need to plot this. Okay, so I rearrange back to cos 2 pi t minus 0.5. Okay, so how did I get 0.5 here? I just factor out this 2 pi. So take out this 2 pi and pi divided by 2 pi equal to 0.5. So from here, we can determine what is the omega and also the duration of this signal function. So omega, we know is equal to 2 pi over t. Okay, so for this equation, this is the omega. So now we can determine that t is equal to 2 pi over 2 pi. So basically, this signal has to be shifted by 0.5 second. Okay, presumably this equation is in second. So 0 minus 0.5 means shift to the right by 0.5. So we know that for the cosine function, okay, the original cosine function is like this. So in order to determine the duration here, that is why we need to find the omega first. And from there we can find the duration. This is 1. Okay, and this is 2 cos 2. So we need to shift by 0.5. So the point at 0.5 here, if this is 1, this is 0.5, and this should be negative 0.5. So the point at negative 0.5, which is here, okay, which is at negative 2 here, should be shifted to the right. So this one should be at x equal to 0. Okay, so for 2 cos 2 pi t minus 0.5, the drawing is like this. Okay, so here is the drawing for st is negative 0.5. Okay, so the same amplitude, which is, so now this signal is being multiplied with ft. So we imagine that ft here is a signal rectangle. So if imagine that if it is superposition here, t is from negative 0.5 to 0.5, and it has a value of magnitude 1. Okay, so it's between this window. However, we have also considered the multiplication process, which the magnitude has to be multiplied together, which is 2 multiplied by 1. Okay, and then for the final gt, okay, it should be only the signals within this window. However, you cannot truncate this. Okay, truncate this part because it is has been multiplied by 2. Okay, so for gt here, the signal will be like this. Okay, only like this. So this is at negative 1 over 2, which is 0.5. So it's easier. This is negative 0.5, and the magnitude here is 2, and this is negative 2. So here is gt, and here is, so this is the answer for sketching the gt. And now we move to question 3. So the question 3 asks to express mathematically the output signal ht and determine all the signals operations involved in this system. Okay, so ht here is gt minus 1. Okay, minus 1. So lucky that we don't have to draw again. Okay, so let us answer here. Question 3 is ht is gt minus 1. So we just write ht is equal to 2 rectangle t cos 2 pi t minus pi, and then we minus this 1. Okay, so if we see here, if we were asked to draw this signal, okay, it is basically the amplitude shifting. Okay, because we minus 1 here, not in the bracket within t. So it is not involving any, when we put -1 here, it doesn't involve any time shifting. It only involves with the amplitude shifting. So the operations involved for the whole equation, you can see that there is a multiplication of the signal between these two rectangle T and also cosine. So this is a multiplication of signal, and then we also have this time shifting. So we have this time shifting, okay, at the cosine, and we also have amplitude shifting here. Okay, so there are three signals operation here, multiplication signal, time shifting, and also amplitude shifting. So now we have answered all question B. And the question, which is taken also from the same question, past year final exam 2015 and 2016. So question C here, consider the two subsystems H and G as defined in this figure. So if we see here, this is a discrete time signals and system from also chapter 1. Okay, so the overall questions give you from just now 1A, 1B, and now is 1C, will give you 25 marks. Okay, so we have two inputs, we have two systems here with the same input Sn, and it's given for question, for question 1 first here, using subsystems H and also G, expressed mathematically the system output Yn in figure Q2C2 in terms of the input Sn. Okay, in terms of the input Sn. So now you have to understand. Okay, there are two systems here. Okay, first, it is given Sn, which go to system H, it will produce x squared n, and another one Sn which goes to system G, it will produce Sn minus S1. Okay, so now using these two systems, there's another system which add together the output from H and also output from G, okay, in order to produce the overall system output, which is Yn. So now we have to write the equation mathematically. All right. Okay, for the first question here, we need to write this Yn. So Yn here is equivalent to the output from H. Let's say this is Y1n, okay, which is x squared n, and also the output from G, which is Y2n. So we put it as Y2. So Y1n here, Y1n here is equivalent to x squared n. So x squared n. Okay, so this is plus. So all the symbols or signs here are also the positive signs. We just have to add xn minus xn minus 1. So that's it for question 1. Simple as that. Okay, so when the question asks you to express mathematically, means you have to derive the equation. Okay, so we go back to question 2 here. Question 2. If the input signal Xn is given as this, determine the system output Yn in Q2C. So if we see here, Xn is given as, okay, let us do it here. Xn is given as 1, 1, 1, 1, 1. However, there is an arrow here, so it indicates that at n equal to 0, the arrow here indicates that the value of Xn when n equal to 0 here is 1. So when we draw Xn here, it has to start at -2. Okay, so here is a -2, -1, 0, 1, and 2. Okay, so this question is quite easy because all values of n here, all values of Xn here is 1. Okay, so this is 1, this is n. Right, so we need to if according to equation here, if according to equation here, we have to determine the system output yn. Okay, so this is xn, and then now we have to draw one by one. So first x squared n. So x squared n will be the same as xn. Okay, because the value here is 1. Unless it is 2, then you have to perform 2 squared 2, which is 4. But because of the values of all xn at all n condition is 1, so this is we just have to put squared here. And then we draw xn minus 1. Okay, we already have xn here. Okay, and then we draw xn minus 1. So for xn minus 1, okay, we just have to shift this xn. Okay, we just have to shift this xn by 1 to the right. So the drawing will start at -1. 0, 1, 2, 3. Okay, and the value of the magnitude for 1. Okay, so this, and then we draw xn minus 1. Okay, so this is the way you do it so that it's easier for you to see the values. Okay, so xn is also equivalent to x squared n, so we just have to minus these 2. So for xn minus xn minus 1, okay, there's no value at n equal to -2 for this one. Okay, this is minus, remember that. So 1 minus 0 is 1. Okay, so we put the value of n first here. So 1 minus 0 is 1. And then 1 minus 1 is 0 here. 1 here, minus 1 is 0 here. Yeah, however, sorry, this is the y-axis. Equal to 1, 1 minus 1 is 0, at n equal to 2, 1 minus 1 is also 0, and then at n equal to 3, 0 minus 1 is -1. So at 3, there is a value of -1 here. Okay, -1 is n, and this is s for this y-axis, this is xn minus 1. Okay, and then we have to add with xn squared. Okay, so you add with this. Okay, this one, add with this, it will produce yn. Okay, so for yn, you just put the value of n first. 1, 2, 3. This is a yn. Okay, so you just add 1 plus 1 at n equal to -2 is 2. So this is a little bit higher. And 1 plus 0 is 1. 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 And then 0 plus -1. 0 plus -1. Yes. 0 plus -1 is -1. Okay. Alright, so if you want to write this in terms of mathematics equation, it will be 1n equivalent to 2, 1, 1, 1, 1, -1. So there will be an arrow here to indicate this is at n equal to 0. Okay, so let us go to the final question. Determine the linearity property of the system yn here in figure Q2C2 and justify your answer. Okay, so we cannot just answer whether it is linear or not. You have to actually justify. So the linearity of yn, linearity of yn. Okay, so we have to go back to our knowledge on linearity. Okay, we can use these two systems in order to determine the linearity. First is either we add together the value of the input first. Okay, x1 and x2n. Okay, add together and then goes into the system that transform the signal, and it will result in yan. Okay, or okay, we can go to the system for each individual input here. Go to the system first. Okay, go to the system. If you remember from chapter 1, we have learned this. And then we add together, become ybn. Okay, so for the first system here, this is yan equal to the transformation of x1n we plus with x2n first, and then only we do the transformation of the signal. Okay, and for this ybn, it is equal to individual transformation of the signal first, x1n, and then plus another transformation of the signal, x2n. Okay, so in this case, if yan is equal to ybn, then the system is linear. And given that the equation here, yn is equal to x squared n plus xn minus xn minus 1. So this is from question 1. Okay, question 1c1. Okay, so if we use as yan first, okay, we put yan first. So the whole equation here, we put in this yan. Okay, so look carefully how we want to justify. Yan is equivalent to, first, we square x1 and x2. Okay, x1 and, okay, we add together x2n, and then only we go to the system which transform the signal, so square. Okay, and the same goes to this, in which we add first x1n plus x2n. Okay, and then goes to the system that minus another time shifting x. Okay, so for this case, this is x1 n minus 1 plus x2 n minus 1. Okay, so look carefully here. Okay, look carefully here. This is actually, if you look here, okay, you actually add together x1 and x2 first, then only you perform the square. And then for here, you add x1 and x2 together, and here you add x1 and x2 n minus 1 together, and then only you perform the minus. Okay, it means that after you add these two signals together, then only you perform this xn minus sn minus 1. Okay, so it should be a plus here. Alright, okay, this should be in the overall bracket. Right, so if we solve for this equation, okay, we will get x1 squared n plus 2x1n x2n plus x2 squared n, okay, for this. And then for this one, n plus x2n minus x1 n minus 1 minus x2 n minus 1. Okay, so this is for yan. Then we'll do the for ybn. Right, for ybn, we have to perform the signal operation first, then only we perform the addition of the output from these two signals operation. Okay, so look carefully here. Means that ybn is equal to x1 squared n, okay, because we perform first the operation, plus x1 n minus x1 n minus 1, okay, and then only we add for input x2n, so which is x2 squared n plus x2n minus x2 n minus 1, right? So this is the first output from the first transformation here, and this is the second output from the second transformation here, which is from x2. Okay, so if we rearrange this, x squared n we put together plus x2 squared n, okay, plus x1n plus x2n minus x1n minus 1 minus x2n minus 1. Okay, so if we see here, we have one extra, if you compare yan and ybn, we have one extra component, which is this. Okay, so it means that yan is not equal to ybn. Okay, so this system is, what do you think, is not linear. Okay, or non, we can also say, non-linear, which is a more accurate terms. Okay, so this is a non-linear system. Okay, so I think that's all for chapter 1 revision. So I have covered plotting of the continuous time, okay, and also plotting for the discrete time, and also the time transformation for both continuous time and discrete time system. Right, thank you very much.